And here's where the story turns even more intriguing. Because if the Inuit carry DNA from both the first migration and a second one, what about the rest of the Americas? Did these later Siberian migrations leave traces beyond the Arctic? The answer might surprise you. When scientists first began sequencing the genomes of ancient Arctic peoples, they expected the story to be a closed chapter. Paleo-Eskimos in the north, replaced by the Thule ancestors of the Inuit. End of story. But DNA doesn't lie, and what it revealed was far stranger. Paleo-Eskimo DNA didn't just vanish into the ice, it traveled. In some indigenous communities of North America, particularly in the Canadian First Nations and in certain Athabascan-speaking peoples of the subarctic, scientists began finding faint but undeniable traces of Paleo-Eskimo ancestry. This meant that there had been contact, intermarriage, and genetic blending between the descendants of the first Americans and these later Siberian arrivals. Think about that for a moment. Populations thousands of miles apart, separated by forests, mountains, and tundra, still found ways to interact. These weren't isolated peoples. They were networks of hunters, traders, and travelers whose paths sometimes crossed in ways we might never have guessed without DNA evidence. For example, research has shown that some Athabascan groups in Alaska and Canada carry between 10 and 25% Paleo-Eskimo ancestry. That's not just a trace, it's a significant inheritance. It suggests that when the ancestors of the Inuit expanded eastward, they didn't do so alone. They left a genetic legacy in the peoples they encountered along the way. And this has bigger implications. It means that the connection between Inuit DNA and Native American DNA is not just about a shared origin in Beringia, it's also about later waves of contact, later moments of exchange, and later blending. The Inuit aren't simply distant cousins of other Native Americans. They're part of a long, complicated family story that kept overlapping and reconnecting across millennia. Imagine the Arctic not as a frozen, empty wasteland, but as a highway of ice and water. Kayaks gliding along the coasts, dog sleds cutting across snowfields, hunters moving between camps. In this vast expanse, people met, traded, and sometimes joined their lives together. Every time that happened, genes moved too, weaving an invisible web that tied communities together across enormous distances. So when a modern Athabascan person in Canada shares a tiny fraction of DNA with an Inuit person in Greenland, that's not a coincidence. It's the echo of an ancient friendship, an ancient marriage, or an ancient alliance carried forward silently in bloodlines for thousands of years. This is one of the great powers of genetics. History often tells us about borders, about divisions, about who belongs where. But DNA tells us something different, that human beings have always been interconnected, even in the most extreme corners of the earth. But there's still a deeper layer to this story, because when scientists looked closely at Inuit DNA, they didn't just find links to Paleo-Eskimos and Native Americans. They found something else, something even older. A ghostly genetic signal from a people long extinct, yet still alive inside Inuit genomes. To uncover this hidden inheritance, we have to look back across the ocean, to Siberia, and to a mysterious population whose genes changed the course of human survival in the Arctic. Just when it seemed the story couldn't get more complex, another voice speaks from the DNA, one not entirely human. Buried deep in the genomes of Inuit and some Native American groups, scientists discovered fragments of DNA that don't match modern humans at all. Instead, they come from an ancient, extinct branch of humanity known as the Denisovans. Tens of thousands of years ago in Asia, before the ancestors of Native Americans ever reached Beringia, our species interbred with Denisovans. The echoes of those encounters are still present today, scattered in small percentages across indigenous genomes. But here's the astonishing part.
Some of those Denisovan genes seem to play a role in cold adaptation. Inuit DNA shows versions of genes that help regulate fat metabolism, body temperature, and energy use in freezing conditions. These traits may have been sharpened by natural selection, but the raw material, those rare variants, likely came from Denisovans. In other words, part of what allowed Inuit peoples to thrive in the Arctic may come from a long-extinct cousin species of humanity. So the connection between Inuit and Native Americans isn't just about geography or migration or survival. It's about being carriers of ancient legacies, some human, some not, that equipped them for their journeys. From the Ice Age plains of Beringia to the frozen seas of Greenland, from the deserts of Mexico to the rainforests of South America, their DNA tells a single story, one of shared beginnings, diverging paths, and hidden reunions. Native Americans and Inuit are not simply neighbors of the same continent. They are branches of the same ancient family tree, twisted and reshaped by time, migration, and adaptation. And even now, their DNA holds the memory of those journeys, reminders that no people on Earth exists in isolation. Our genomes are proof that human history is never a straight line. It's a web, a braid, a tapestry, and every thread, no matter how distant, is still connected.